Hello everyone, welcome to Rejuvenating Club. Let's inspire, let's grow, episode 24.
Greetings to one and all. I am ANJANA JAYARAJ from Vedavyasa Institute of Technology, first year civil. In this presentation, I am going to explain on the topic thermal bridging. This presentation includes following topic: concept, introduction, example, identification, classification, effective way to reduce. Concept: heat transfer occurs through three mechanisms: conduction, convection, and radiation. Conduction is the transfer of energy from one molecule to another by direct contact. Convection is the movement of heat by fluids such as water or air. Radiation is the transfer of heat by electromagnetic wave, and the rate of heat of transfer depend on thermal conductivity of the material and temperature difference experienced either side of the thermal bridge. Introduction: thermal bridging caused by highly conductive element that penetrate thermal insulation. These paths allow heat flow to bypass the insulation layer and reduce the effectiveness of the insulation and the overall building thermal envelope. A thermal bridge, also called a cold bridge, heat bridge, or thermal bypass, is an area or component of an object which has higher thermal conductivity than the surrounding materials, creating a path of least resistance for heat transfer. Where two parts of the building meet at junctions, example, window reveals, eaves, flat roof or gable, wall junction, etc. Heat flow can be increased due to structural components, penetrating insulation, poor detailing by designer, and poor insulation by trades. Examples: brick wall lintel, wall or slab on ground junction, window or wall junction, steel pillar studs and sills integrated in building elements. Identifying thermal bridges. Surveying building for thermal bridging is performed using passive infrared thermography. Infrared thermography of building can allow thermal signature that indicate heat leaks. Infrared thermography detects thermal abnormalities that are linked to the movement of fluid through building elements, highlighting the variations in the thermal properties of the material that correspondingly cause a major change in the temperature. Automated analysis approaches such as laser scanning technologies can provide thermal images on three-dimensional CAD model surface and material information to thermographic analysis. Classification of thermal bridge including three basic types. First one is repeating thermal bridges. Repeating thermal bridges, which are usually evenly distributed over the building envelope and follow a regular path. These are mostly likely to occur in insulated cold pitched roof at ceiling joints, insulated suspended timber, floor at ground floor joints, timber frame construction, steel wall tiles in masonry wall, or mortar joints in inner wall leaves. Second one is non-repeating thermal bridges. Non-repeating thermal bridges are mostly commonly caused by discontinuities in the building envelope and can appear around openings such as windows and door openings, around loft hatches. Geometrical thermal bridges are dependent internal wall and shape of the structure and can appear as two-dimensional or three-dimensional. Usually occurs at external wall corners and at junctions including window and wall or door and wall junctions, wall and roof junctions, wall and floor junctions, or adjacent wall junctions. Effect of thermal bridges. Thermal bridging can result in increased energy required to heat or cool a conditioned space due to winter heat loss and summer heat gain. At interior locations near thermal bridges, occupants may experience thermal discomfort due to the difference in temperature. Additionally, when the temperature difference between indoor and outdoor space is large and there is warm and humid air indoors, such as a condition experienced in the winter, There is a risk of condensation in the building envelope due to cooler temperature on the interior surface at thermal bridge location. Way to reduce thermal bridging. A continuous thermal insulation layer in the thermal envelope, such as with rigid foam board insulation. Lapping of insulation where direct continuity is not possible. Double-end staggered wall assemblies. Structural insulated panels and insulating concrete forms. Reducing framing factor by eliminating unnecessary framing members such as implemented with advanced framing. Raised heel trusses at wall to roof junction to increase insulation depth. I hope this presentation is helpful to everyone. Thank you.